I always know when we're getting to the end of the year when we hit absolute values. They seem to put them at the end of every book. Alright, you probably remember absolute values. If I did the absolute value of -2, remember what the answer is? Absolute value is simply the distance from 0 to a point on the number line. So if we went from 0 to -2 on the number line, the distance would be 2. Absolute value is always positive. So keeping that in mind, we're going to try to solve some absolute value inequalities. Here's the definition. The absolute value of a non-zero real number is a positive number. The absolute value of 0 is 0. We're going to graph these. We want all the numbers whose absolute value is greater than 2. So let's just try a couple numbers. So if we put in 1, would that work? The absolute value of 1 is 1. Is 1 greater than 2? No. Let's put in 4. Is the absolute value of 4 greater than 2? Yes, 4 is greater than 2, so that works. Let's try some negative numbers. If I put in a -2, would that work? -2, the absolute value of a -2 is 2. Is 2 greater than 0? It's equal to 0, but it's not greater, so that one doesn't work. If we put a 0 in, 0 is greater than -2? Nope. How about a -5? Absolute -5 would be +5. Is +5 greater than 2? Yes. If we have greater than for absolute value problems, we learn different ways to do this later. We have to find on the number line every real number whose absolute value is greater than 2. So we can see that what we're going to get here is it's not going to be -2 or 2, so we put an open circle on -2 and 2, but any positive number greater than 2 is going to make this true. So we're going to fill in every number greater than 2 this way, and it's going to work also for the negative numbers, because if we take the absolute value of a negative number, it's going to become a positive number, so it's going to be the same way. If you have an absolute value with a greater than, you're going to end up coloring out away from 0. If the absolute value is less than, we're going to be coloring in between the 2 points. So later we're going to learn a more algebraic way to do these, but for now, like if we have x is greater than 2, that would have been an easy problem for you. You would have just taken 0, 1, 2, and you would have put an open circle and colored it this way. So it's going to be the same thing when the absolute value is just going to be all the negative numbers also. Let's try another one. The absolute value of x is less than or equal to 3. So you're going to end up putting a point, since it's absolute value and it's equal to, you're going to put a point on 3 and on -3. Now this time all the values have to be less than 3. So a 2 would work, a 1 would work, a 0 is less than 3, a -1, the absolute value of -1 is less than 3, the absolute value of -2 is less than 3. So all the values inside of here work. So we can color all these in. Now let's try some outside and see if they work, just for a check. If I put a 4 in, 4 is not less than 3. -5, the absolute value of -5 is +5, and that's not less than 3. So these are our solutions. So as I said, if it's greater than, you're going to color outside from the points. If it's less than, you're going to color in between them. But we're going to get more complicated here. The absolute value of x is less than -4. Now this is tricky and you have to actually think. So if I put a 3 in here, is +3 less than -4? +3 less than -4? No. If I put a 0 in, is 0 less than -4? No. If I put a -5 in here, the absolute value is going to make it positive. So what you see is we can't have an absolute value that's negative, so there's nothing that we can fill in here that will make this true. You can't have the absolute value of a number that is negative. So this one, there is no solution. You can write all different things for this. You can write the empty set like this, or, whoops, my pen's not ready all of a sudden. Or you can have the empty braces, or you can say no solution. Watch out for that. That'll come in tricky because you'll start putting your points on 4 or -4 and coloring between, but you can't do a negative number. Let's try another one you're going to have to think about. The absolute value of a number is greater than -4. Well, this is different. This is greater than. Everything is going to be greater if it's made positive than a negative number. So if you have the absolute value is greater than a negative number, it's going to be all the numbers, because absolute value are all positive numbers, and all positive numbers are greater than a negative number. So you're going to color in everything. If I put a -100 in there, that's going to be greater than 0. If I put greater than -4. If I put a 3 in there, 3 is greater than -4. Everything, when you take the absolute value of it, it's going to be positive, and all positive numbers are greater than negative numbers. Okay, I'm on to more complications here. The absolute value of x is greater than or equal to -3. Here we go again. I think I copied this problem down wrong. Yes, there should be a negative right there. Now, you need to get the absolute value by itself, but there's a negative 1 before it, so you need to divide both sides by a -1 before you begin this problem. Now, the tricky part for this is anytime you divide an inequality by a negative number, the inequality sign flips. So these are going to become positive, so it's going to be the absolute value of x. Flip our inequality sign. Flip. Because we're dividing by a negative. If you multiply or divide by a negative, the inequality sign does a flip. And we're going to get, it stays and equal to, it just the direction changes. And so we're going to get less than or equal to 3. If it's a positive number, you put a dot on 3 and a dot on -3. If it's and equal to, if it's just absolute value of x is less than 3, you put an open circle on 3. You want all the values that are going to be less than 3. Well, we know it's going to be 2. Once you get 1 in the zone that works, they're all going to work. So we color all these in. Remember, less than is going to be in between the 2 dots. Greater than is going to be outside the dots. You can check points. You have the 2 points are going to divide it into 3 zones. You're going to have 1, 2, and 3. If you check a point inside of the points and it works, then you're going to color in between. If it doesn't work, you color outside. Or you can just remember, if it's less than, it's in between. Alright, let's try another one. And this is the last one, and then we'll do one on your own. Okay, you have to get the absolute value by itself. So I'm going to get negative x is greater than, if I add 2, it's going to be -3. I added 2, just in case you need that extra step. Now I'm going to divide both sides by -1 to get the absolute value by itself. And when I do that, the sign flips. Don't forget to do that. So we're going to get the absolute value of x is less than 3. And like I said, it's going to be not equal to, so you put a dot on open circle on 3 and -3. It's all the values less than 3, so if I put a 0 in, 0 is less than 3, so I have a point that works inside of here, so they're all going to work. So we color that all in like that. Alright, let's try one on your own. I'm going to do practice problem A, or have you do it, so you try this one. It is negative absolute value of x minus 9 is greater than negative 11. I'm going to stop the video and turn it on in just a minute. Okay, let's see if you got this. Negative absolute value of x is greater than negative, I'm going to add 9 to both sides, -2. Divide both sides by -1. So we get x is less than, flip the sign because we're dividing by -2. These are all really similar, aren't they? So 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. Open circle on 2 and -2. We want all the absolute value, I forgot my absolute values after all that, have to be less than 2. 0 works, so I'm going to color everything in between. Hopefully you got that. Any questions, I'll answer in a minute. And that's it for lesson 102.